let v equal to r power 3. T is vector space to vector space, be the linear transformation defined by t of x comma y comma z equal to 2x comma 4y comma 5z. We must find the matrix T with respect to the basis 2 comma 2 by 3 comma 0 comma 0 0 1 by 2 0 0 0 1 by 4 of V. So here solution. So here for reference, standard basis is nothing but E1 1 0 0, E2 is 0 1 0, E3 is 0 0 1. Here we have the basis 2 by 3 0 0 as E1, E2 is 0 1 by 2 0, E3 is 0 0 1 by 4. We have the function t of x comma y. So here first we substitute t of E1, that is t of 2 by 3 comma 0 comma 0 in the given function. So here x is 2 by 3. So here if we substitute 2 into 2 by 3 and y is 0, z is 0, so we get 0 here. So this is nothing but 4 by 3 comma 0 comma 0. And t of E2, E2 is, we have the basis, we must consider 0 1 by 2 0 0 1 by 2 0, we get 2 times 0 is 0, 4 times 1 by 2 and z is 0. We get the answer 0 2 comma 0. So t of E3 is t of 0 comma 0 comma 1 by 4. This value we substitute in the given function 2x comma 4y comma 5z. If we substitute x equal to 0, we get 0, y is 0, so 4y becomes 0, 5z is there, 5z is 1 by 4, we get 0 comma 0 comma 5 by 4. So here we have 3 values. Here to find out the matrix, we must substitute in t of E1 equal to C1 into E1 plus C2 into E2 plus C3 into E3. So here t of E1 is 4 by 3 comma 0 comma 0, 4 by 3 comma 0 comma 0. We must find out the coordinate vectors C1. So C1 E1 is 2 by 3 comma 0 comma 0, 2 by 3 comma 0 comma 0 plus C2 and into E2 is, here we have E2 0 1 by 2 0 plus C3 into 0 comma 0 comma 1 by 4. So here if we multiply this one, we get 2 times C1 by 3 and here C2 is 0 if we multiply, and C3 is 0, then we get so we must add the x elements. We get 2 times C1 by 3. Adding the y elements, we get only C2 and C3 by 4 for the last one. Now we equate these values. This is diagonal elements, that is we have only x coordinates here. If we compare this one with the right hand side, we can write 4 by 3 is equal to 2 times C1 by 3. 1 by 2 into C2 is 0. C3 by 4 is 0. So we get the answer. Here 3 get cancelled. 2 and 4 we can cancel. We get C1 is 2, C2 is 0, C3 is 0. So we have the values 2, 0, 0. So we have some equation number. Similarly, T of E2 is so T of E2 is 0, 2, 0 equal to, we must find out these values. Already we have written, so here we write this step straight away. We write this step straight away. 2 C1 by 3, C2 by 2, C3 by 4. Now if we compare these two, we get 2 C1 by 3 is 0, 2 is C2 by 2, 0 is C3 by 4. So we can simplify this one. We get C1 is 0, C2 is 4, C3 is 0. So we have this as equation number 2. Similarly, T of E3 is we have the values 0, 0, 5 by 4. So we write it here 0, 0, 5 by 4. We equate with 2 times C1 by 3, C2 by 2, C3 by 4. So if we equate this one, we can write C1 is 0, C2 is 0 and C3 by 4 is equal to 5 by 4. So here we are equating these two. 4 get cancelled, we get C3 equal to 5. So here, so we have the transformation with respect to the basis. So equation number 1. So what is equation number 1? We have 2. We write it in terms of column, and equation number 2 is 0, 4, 0, and equation number 3 is 0, 0, 5. This is nothing but matrix of T for the basis 2 by 3, 0, 0, 0, 1 by 2, 0, and 0 0 1 by 4.